Okay, this video is for your section 6-2 notes, determinants, and inverse matrices. So we're just going to dive in here. We have a formula for finding the determinant of a 2x2 matrix, and then we're going to work through this example. So we have this formula. So the general formula, so we abbreviate determinant DET. And then if you have some general matrix A, B, C, D, the determinant is A times D minus C times B. So pretty straightforward. We have another 2x2 matrix, so we want the determinant of this matrix A. So we need to do across this diagonal 4 times 6, which would be my A times D, and then subtract 7 times -2. So pretty straightforward. So that's going to be 4 times 6 minus -2 times 7. And when we simplify that, we should get 38. So the determinant, DET, of matrix A equals 38. Sometimes we also just, instead of writing DET, we just kind of use the absolute value bars here. So we could write the same thing by just doing this. And that also means the determinant of matrix A is 38. Now, this is for a 2x2 matrix. The formula, the method we use, changes a little bit based on the size of the matrix. So this is for a 2x2. Now let's look at a 3x3. So here we want the determinant of matrix B. And so we can see that matrix B is 3x3. This formula looks kind of crazy. But if we look through what they're saying to us here, it's really not too bad. It's actually something we've done before. It just looks a little different. So what they're saying here, when you have the A on the outside and then the vertical bar, well, like we just said, that vertical bar, that sort of absolute value, means that's the determinant. And so this is the determinant of the 2x2 matrix EF HK. And then B times the determinant of the 2x2 matrix DKFG, and then C times the determinant of this 2x2 matrix. At first, when you look at that, that's like, whoa, what the letters is going on here? But notice the numbers on the outside, A, B, C, that's the first row. And then the 2x2 matrix is just, okay, ignore that first row, and then look at the bottom 2 rows and pick the 2 columns that you didn't pull initially. So if I pull A, that's in row 1, column 1. So it's in the first column. So we're ignoring the first row, and since A is in the first column, ignore the first column and do EF HK. B, so B is in the second column, so ignore this EH, and you've got DG FK. C, third column, so ignore the third column FK, and just choose the remaining 2x2. And then because it's the determinant, what you're going to do is you're going to do E times K minus F times H, and D times K minus F times G, and D times H minus E times G, just like we did for the 2x2 on the previous page. So it's really not that bad to think about that way. But there's actually another way that we can think about this, which is helpful because we've done it before. If you look at the math that we're doing here, it's actually identical to back in our vector chapter when we did the cross product. So if I just take this matrix and write it like we did with the vectors, and I rewrite the first 2 columns here, 3, 2, 0, and 1, -1. I always have a hard time with my negatives with this cheap old stylist I have. Stylus, not stylist. And this is actually going to follow the exact same pattern as that cross product that we did back in chapter, whatever chapter the vector chapter is. I can't remember off the top of my head right now. So first, I would multiply 3 times -1 times 2. And then later, when I come back, I'm going to multiply 3 times 1 times 4. Well, that's exactly what they've told me to do here. Pull out the 3. Let's not do that. Pull out the 3. And then multiply EK and FH. And then just distribute a 3 to both of those things. So it's the exact same math. So whichever way makes more sense to you, either this kind of 3-part determinant with a scalar multiple on the outside, or coming back and doing this cross product idea. To me, the cross product makes it a little easier. It's just something that works better in my brain, but either way is fine. So I'm just going to finish this up. So let's keep writing here. So we did 3 times -1 times 2. And then I'm just going to do like we did with the cross product, where I keep going with my top left to bottom right diagonals. So then I add to that plus 1 times 1 times 0. Plus my next top left to bottom right diagonal is -1 times 2 times 4. And again, all of that is just taking this number on the outside and then doing the multiplication from top left to bottom right, just like you would in these 2 by 2 determinants. Then we go the other way. So now I have 3 times 1 times 4. And if you remember from the cross product, we're subtracting now that we go the other way. So I have 3 times 1 times 4, and then I'm going to have 1 times 2 times 2, and then one more to subtract here, kind of running out of room. Back this one, -1 times -1 times 0. -1, 0. And when I simplify all of that, I should get -30. And so that's how we find the determinant of a 3 by 3 matrix. 2 by 2, super straightforward. 3 by 3, a little more complicated, but it's something we've done before. And again, there's 2 ways you can look at it. If you prefer to look at it the cross product way, where you're building on what we did back in our vector chapter, or if you prefer to look at it this way, where you're simply doing 3 2 by 2 determinants, either way is going to get you the same answer. So whichever is more comfortable for you is really fine here. And that's determinants. You can find determinants of other sized matrices. They do have to be square, so 2 by 2, 3 by 3, 4 by 4, etc. 2 by 2 and 3 by 3, I'm going to ask you to do those by hand. anything bigger than 3 by 3, a 4 by 4, 5 by 5, 9 by 9, the process is just more involved than is helpful, and so we're just going to do those on our calculator, and we'll look at how to do that on the calculator in just a minute. Okay, so that's the determinant. Now we're going to look at a couple other things today. That was determinant. So I'm going to go ahead and stop the video here. We've got, I think I'll just break it up into a few different chunks. So that was determinant, and then we'll start with a separate video. That way when you look back, if you have questions, things are more easily sorted through to find which piece you're looking for.